So an overview of the functional groups, again, the formula is always like this. You have R, which is only carbon, 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 hydrogen, sigma bonds. And then you have the functional group. Now, that's not to say there's only one functional group. There could be multiple functional groups, as you will see. The functional groups, as we said before, can be divided into hydrocarbons that contain pi bonds. We're going to see that some of these here. Compounds that contain CZ sigma bonds, where Z is the electronegative atom. So again, that could be oxygen, that could be nitrogen, that could be a halogen, you know, F, Cl, Br, I, etc., sulfur, etc. And then compounds that contain carbon, oxygen double bonds and carbon, nitrogen triple bonds. This is called a carbonyl. This is called a cyano or nitrile. So we're going to learn just how to identify these next semester. In the next semester, you're going to learn how to use them. Okay, quickly, hydrocarbons. Well, alkanes are not functional groups. Those are just simply carbon, 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 hydrogen sigma bonds. So there are no functional groups. Well, let's look at an example we just did. So if I have propane, which is this, all I see is carbon, 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 hydrogen, sigma bonds. All of these are, again, sigma bonds. So carbon, 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 hydrogen, sigma bonds. So those are the boring part. So they always look like this in a skeletal structure. Once again, or if they were rings, they would look like this. For example, there's nothing special. Alkenes, they have double bonds. So here's an example. Well, that's a pi bond. So you have to be able to right away say no more, or it's not a sigma bond. So that's a pi bond. And that counts as, again, a functional group. And then finally, if you have a triple bond, these are what we call alkynes, and we're going to study their reactions at the end of this semester. And again, these are electrons. So here you have actually two pi bonds. So both of these are electron rich. Electron rich. Now, you might think that, okay, well, I have double bonds, so these are, again, alkenes. Well, not in this ring structure. These become aromatics. They're aromatic compounds. Anytime we have, for example, 3 double bonds in a 6-membered ring, this is called a benzene. So these are aromatics, and they will be studied next semester. The simplest one, again, is benzene, and it's attached. It would be a phenyl group. So be able to recognize that this is an aromatic. And they're called aromatics because, again, they have distinct smells. So here are the functional groups. What you should be doing is you should be committing these to memory. They will not be allowed to use on a test because everyone in organic chemistry must recognize the common functional groups. It makes no sense for someone going into pharmacology, pharmacy, even medicine, not knowing what an alcohol is. So what you should be doing is you should be remembering the general structure. And of course, here's an example to help you. So the compounds, the functional groups which eventually translates into the type of compounds, are right here. So if you have an OH attached to a chain of carbons, however many carbons there are, those are called alcohols. Like this is methanol or wood alcohol, very dangerous. An aldehyde, it would have this functional group right here. It would be a C double bond O, and then of course a CH single bond. That's called an aldehyde. So here's an example. This is acetaldehyde, acetaldehyde. This is very toxic to the liver. It's basically when someone drinks too much ethanol from liquor, from alcoholic drinks, this is what gets metabolized, and of course it kills liver cells, to put it very, very simplistically. So alkenes, they have carbon-carbon double bonds. Alkyl halides, they have the halides, so they have the fluorine, the Cl, the Br, so on and so forth. So you should be committing all of these to memory and be able to apply them here. So let's apply that here. So common question is, identify the functional group in tetracycline, which is an antibiotic. Now, why is this an important procedure? Because if you don't know the functional group, you don't know what reactions it's going to undergo. So once again, let's actually relate this to it. So I'm going to look around and see what functional groups I have. I'm going to start with the easy ones. Anytime I have an OH, of course, that's going to be an alcohol. So sometimes they might merge. So that's an alcohol. That's an alcohol. There's another one. There's another one. So you have a bunch of these. And there's another one. Okay, I'm keeping it this way so you can see it. So once again, here it is, an alcohol. Okay, let's see what else we have. Well, I have a benzene ring, an aromatic, remember? Right here, an aromatic compound. So you can call it an aromatic. I only have one. Okay, I'm finished with the alcohol and the aromatics. Let's see what else I have. I have an N. Now be careful about this one. So I have an N with 3 bonds here. Let me go look. Well, that's an amine. That's an amine. An R, again, could be other carbons attached. So that would be an amine right here. What else do you think we have? You can pause and think about this example. So we also have, I see double bonds here, not these, this one. So I have a double bond here and a double bond there. So in green here, I'm going to just write it on the side. These are alkenes, an alkene right here. Very well, we're almost finished. We have 2 more left. So I'm going to use the highlighting here so we can see it. Well, it looks like we have a carbon-oxygen double bond. So we're going to highlight this. And let's see, be careful because you have many of these, so you can't just pick out any of them. It has to match. So you have a carbon, and then it's attached to 2 C's because these are carbons right here. So let me write that down so you don't forget that. These are carbons, right? Well, if it's attached to two carbons, then that would be called a ketone. A ketone. So you heard of the keto diet immune test because it produces ketones. So that's a ketone. A ketone. What else? We have one more. We have actually two more. Here's another ketone. What else do we have? Let me use a different color here. Well, it looks like we also have a carbonyl here. But be careful. Sometimes this is a common mistake, is that students think that this is a carbonyl and then there's an amine. Nope. Look more carefully. So if we look around here, look around, look around and keep looking, we find that there's something called an amide, where you have an amine attached to a carbonyl. Well, this is called an amide. This is called an amide. And the reason why it has its functional groups is because it has different reactions than amines by themselves. Reactivity is different. Even its spectrum, right? How to look for it and identify it is different. So that would be an amide. In fact, an amide is the organochemical name for the peptide bond. This is nothing but a peptide. So there you go. These are your functional groups. Practice enough of these, and it's generally not there's no issue with these.